So now we'll move on to the idea of a remainder in modular arithmetic. Now, why do we say remainder? It is because the number that 13 is congruent to is found by dividing 13 by the modulus and then finding the remainder. So in this case, it is 13 over 12. Now 12 goes into 13 once. So 12, 1, 12 plus 1, which is the remainder. So the remainder is the one here. The one here is the remainder. Okay, the same for 16. Now, how do we find the modulus of 16 or 12? We divide 16 by the modulus, and then 12 goes into 16 once, remainder 4. Or you can use the table form of division to arrive at the same answer. So that is how we use the concept of remainder to find the modulus of a certain number. Now, we need to note that sometimes the operation of finding the remainder is referred to as the modulo operation. So not only in mathematics, but also in programming, for instance, when reference is made to the modulo operator, we are talking about the remainder after a certain calculation is done. Now, let's see some examples. Consider this question. What is 12 in modulo 5? Sometimes this question is written as 12 mod 5. We understand that find 12 in modulo 5. Now, how do we do it? We simply divide the number by the modulus, and the remainder is the answer. Okay, so in this case, we want to find 12 in modulo 5 or 12 mod 5. So we divide 12 by 5, which is the modulus, and then we get 5 will go into 12 twice. So 5, 2 is 10, remainder 2. So the remainder is the answer. So 12 mod 5 is congruent to 2. Now take note again, we don't say equal to, we say congruent, which is why in this lesson we want to use the congruency symbol rather than the equal to symbol. So let's remind ourselves that this is read as 12 mod 5 is congruent to 2. Good. So in general, we say that a certain number is congruent to a certain number mod n when the number divided by the modulus leaves a remainder of b. So in this case, we say that 12 is congruent to 2 in modulus 5. 12 is congruent to 2 modulus 5. What we mean by that is when we divide 12 by modulus 5, we get a remainder of 2. Okay. Now let's see some examples. Calculate the value of the number, in this case positive numbers, in a given modulo. So we are going to find the number 26, 3, and 13 in modulo 5. So what we do is we simply divide the number by the modulus, which is 5, and then we take the remainder. So 26 is congruent to 1 mod 5. As simple as that. What about the number 3? Now 3 is less than the modulus, or 5 in this case. Therefore, it retains the same value. So we don't do anything to it. So 3 is equivalent to 3 in mod 5. Now what about the number 13 in mod 5? You divide 13 by 5 and we get 2. So 5, 2 is 10, remainder 3. So 3 to 13 in modulus 5 is congruent to 3 modulus 5. That is the answer. Now we can draw our own modulo value ring to help us to find the value of certain numbers or certain calculation in certain modulus. For instance, if we were given modulo 5 as we solved in these 3 examples, if we were to draw the modulo ring 1, 2, 3, 4, 5, so these are the numbers in the modulo ring or modulo 5. Now, how do we arrive at the values? Now, if the numbers are less than the modulus, which is 5, it is the same value. So 1 is 1 in modulo 5, 2 is 2 in modulo 5, 3 is 3 in modulo 5, 4 is 4 in modulo. But what about 5, the number 5 itself? Now, if you divide 5 by 5, you will get 1 remainder 0. Now, it's the remainder we are interested in. So the value of 5 in modulo 5 is 0. Okay, because when we divide 5 by 5, we get 1 remainder 0. Now, the value for the other numbers on the same line as 5 is also 0. For example, the number on the second cycle of numbers is obtained by adding the modulus to the number. For example, if you add the modulus 5 to 5, you get 10. If you add the number 5 to 1, you get 6. If you add the number 5 to 2, you get 7. 3 plus 5, 8, 4 plus 5, 9, etc. So all the numbers on the same side as 5 have the value in modulus 5 as 0. So all the numbers also here on the same line as 1, 6, 11, 26, etc. also all have the same value of 1 in modulus 5. So that is how to use the modular ring that we have just drawn to find the value of the numbers in a modulo set of numbers.